How does a fire pump work? Mechanically, how does a fire pump work? There are several components to a fire pump system. Each is necessary for the fire pump to function as intended. The pump appliance itself, the powered drive component, the jockey or pressure maintenance pump, the fire pump controller, and the jockey pump controller are all critical components of the system as a whole. In this segment, we're going to discuss the actual fire pump appliance itself. In later segments, we'll identify each of the other components and discuss their function and contribution to the aggregate system. The fire pump itself is relatively simple. Regardless of the type of pump used, the concept is basically the same. The pump is equipped with an impeller. The impeller is located within the fire pump's housing. As the impeller turns, water flings to the outer walls of the pump housing, which in turn places force into the mass. This force of mass in turn creates pressure and velocity. Velocity is the movement of the water. The fire pump controller sits in a large metal cabinet in the pump room and serves as the brain of the system. Typically, when a fire pump is installed, sensing lines are installed from the discharge side of the pump and then connected to the fire pump controller. Now, we'll discuss this in greater detail in later segments, but for now, it's important to know that when the fire pump controller senses a predetermined drop in pressure on the system side, it pretty much presumes that water is flowing somewhere in the building and the fire pump is needed to provide adequate pressure. The fire pump controller then tells the drive component to start, thus turning the impeller in the pump, which does its thing. Like we just discussed, the motion of the impeller then creates the pressure and velocity or movement of the water into the automatic sprinkler, standpipe, or water mist system. We should note that although pressure drop is generally the most common method the fire pump controller uses to tell the fire pump when to start, alternatively, the controller may use a water flow condition as identified by a flow switch. Either way, the controller is directing the drive component to do its thing and power the pump. Additionally, it's important to remember that once a fire pump starts, it must be shut down manually. No automatic shutdown is permitted. It's not some sort of dark magic as to how the impeller does its job. It's just science. If we were to look at an impeller, we would see that it has what could be described as blades. As the impeller turns, the liquid is radially pushed outward in all directions to the edge of the impeller. As the liquid is pushed outward, this creates an area of lower pressure toward the center of the impeller. You've probably heard it said that nature abhors a vacuum, and that's true. This area of lower pressure near the center of the impeller pulls more liquid into the intake of the pump. The liquid continues to get trapped between the blades or the vanes of the impeller. As the impeller continues to rotate, it creates velocity or movement of the water, creating kinetic energy as it reaches the outer edge of the impeller. By the time the liquid reaches the outer edge of the impeller, it's moving at a higher velocity. The liquid exits the impeller and impacts the pump casing, where the kinetic energy we just identified converts to potential energy or pressure. As this continues to happen, more liquid follows behind, and this process generates the rate of flow. The fire pump has a device called a volute channel downstream of the impeller. This volute channel resembles sort of a curved funnel. This funnel increases in diameter as it approaches the pump discharge flange. As the liquid passes through the expanding diameter of the volute channel, the velocity of the water decreases. This is because the liquid has a little more physical room in the area. This action of the decreasing velocity of the liquid causes the potential energy or pressure to increase. The liquid then exits through the discharge flange at a much higher pressure than entered through the intake flange. Electric drive is one of the 3 drive means NFPA 20 allows for a fire pump. We'll discuss the other allowable drive means in a later segment, but electric drive is often preferable. There's less maintenance involved, they're cheaper, etc. However, electric drive motors for fire pumps need to be supplied with 3-phase electrical service. If 3-phase electrical service is not available at the project location, you won't be able to use an electric drive motor, then using a vertical inline pump is not an option. You'll have to look at other pump types. In this segment, we explored the mechanics behind how a fire pump generates movement and pressure of the liquid. The fire pump creates movement of the water, which then generates pressure. I'm Jesse Cecil. This is MeyerFire University.
This has been a preview of MeyerFire University. Join the next generation of fire protection experts at www.meyerfireuniversity.com.